going to teach you all about polynomials according to the beginning algebra book in chapter 7.
The first thing you've got to know is what a monomial and a polynomial are. A good way to remember that is just that mono means one and poly means many. So a monomial would be something like 3x, and a polynomial would be something like 3x plus 4x plus 5x, because 3x, 4x, and 5x are all monomials. So polynomials are made of monomials. Now there's more than one type of polynomial. There are binomials that are made up of two monomials, so something like 4x plus 2. And there's also trinomials with three monomials, which would be something like 7x to the power of 2 plus 5x minus 7. But they're all under the category of polynomials. Now I am going to tell you how to add and subtract and multiply polynomials and all that kind of thing, but first, before I do that, you need to know about descending order. For equations with polynomials, put the terms in order from largest to smallest based on the exponents. So here you have 2x to the power of 3 plus 2x to the power of 2 plus 2. In each case you have an x, except for the very last case, with an exponent. First you have 3, 2, and then 1. You always want to make sure that anytime you're working with exponents, doing anything at all with exponents and polynomials, that it goes in descending order. It just makes everything easier so that when you have to write out your answer, it's always going to be in the right form. Now that you know about descending order, I can teach you how to add polynomials. You can use that in equations like this. 2x to the power of 2 plus x minus 1, that whole thing, plus 3x to the power of 3 plus 4x to the power of 2 minus 5. The way you can figure that out is to stack the polynomials on top of each other so that their terms are in one column. Their like terms are in one column. So here you can see they're stacked above each other. You have the 2x to the power of 2 and the 4x to the power of 2 in the same column because they each share an x to the power of 2. You also have the 1 and the 5 over each other because neither one of them has an x to the power of anything. This way you can add them all up. Nothing is added up to 3x to the power of 3, but you add the 2x to the power of 2 and the 4x to the power of 2 together. And that should give you 6x to the power of 2. Then you have to add the negative 1 and the negative 5 together. And ultimately you get this answer. 3x to the power of 3 plus 6x to the power of 2 plus x plus negative 6. You still have the 3x to the negative 3 and the x because neither one of those was added to anything because one of the equations did not have a term that fit that term. Now we can do subtracting polynomials. It's pretty much the same as the process that went into doing the addition of polynomials. You have to make sure that the terms are in descending order, and then you do the same thing but before. So you basically stack the polynomials on top of each other. So here's our equation. Before you can stack them though, you have to make sure that you distribute the negative. You see how you have the second polynomial, and inside those parentheses is a negative number? Well, you don't want to get that confused, so you take the negative that is outside of those parentheses and you distribute that to all of the numbers that are inside of the parentheses before you can stack them on top of each other. And that's what that equation would look like. Negative 3x to the power of 2 minus 7 minus 8x to the power of 2 minus 3x plus 4. You see that you have the 2x to the power of 2's on top of each other and the 7 and the 4. The answer would be 5x to the power of 2 minus 3x minus 3. Now that we've done addition and subtraction, we can move on to multiplication. When you're multiplying these kind of things, you want to keep in mind that when you multiply exponents, it's the same as adding them together. For example, 2x to the power of 2 times x is the same thing as 2x to the power of 3. You had x to the power of 2 and an x, which is saying that x is basically to the power of 1. So you're adding 2 and 1 to make 3. So here's an equation. 2xy times 3x to the power of 2 times y. What you have to do is you have to multiply all the like terms together. So that includes the 2 and the 3, the x's, and the y's. So it'd be something like this. Now you have the x times the x squared. You know from the previous rule that I just showed you that the x squared and the x will go together to make x to the power of 3. Same thing's going to happen with the y. So you're going to end up with 6x to the power of 3 times y to the power of 2. Now the multiplication of polynomials is going to get a little bit more tricky. A good way to do it is to stack things on top of each other like we were doing for addition and subtraction. Except the only difference is that when you're doing multiplication, you can't do everything all in one go. So you multiply that whole top part times the 3, not the 2b, but just the 3 at first. And you get one answer. And then you have to do the same thing for the 2b. And you get a whole separate answer. Then you have to add those two answers together. And that will end in the result that you want to get. Just make sure that it's going down into descending order, and that should be the right answer. You probably think I'm going to teach you how to divide now, but actually I can't do that yet. There's a bunch of things you have to know first. Dividing is actually a lot more complicated than adding and subtracting. First, before you learn how to divide, you need to know about integer exponents and scientific notation. Okay, so you're probably already familiar with the rule that says that x to the power 5 is equal to x times x times x times x times x. That'll be helpful in doing these polynomial division problems. So here's an equation. You have x to the power 5 over x to the power of 2. And writing it out in the extended form can be helpful. What you have to do is cancel all the x's you possibly can. So the same amount of the bottom as in the top. So basically you take the fewest amount of x's that are in the denominator or the numerator and cancel them from both the top and the bottom. So you can do 2 from both, and that leaves you with x to the power of 3. So now you need to know about scientific notation. Scientific notation is just a way to express really big numbers or really small numbers using exponents. So say you have a really big number like that. It can be, kind of frustrating to have to write out every single zero because it's really, really long. So you want to figure out how to write it in scientific notation. What you have to do is you have to count all the individual numbers all the way up to that first 3. And you're going to put a decimal right behind that first 3. Now there are 9 other numbers besides that 3. So first you put the decimal point there, and then you just forget about all the rest of those zeros, but just keep in mind that there were 9 numbers, not just the zeros, but 9 numbers besides that 3. And then you write 3.45 times 10 to the power of 9, because there were 9 numbers. And that's scientific notation. So now we're actually ready to divide polynomials. So here is what one kind of equation would look like. So you've got 12x to the power of 2 times y minus 6x times y plus 4x to the power of 2 all over 2xy. Now, basically what you got to do is just divide each of the terms in the top part by the monomial in the bottom. So basically you're dividing 12 by 2, 6 by 2, and 4 by 2. You're also dividing each of the x's by the x on the bottom and the y's by the y on the bottom. So you're going to have x's and y's cancel out. So every time you have an x to the power of 2 divided by x, you're just going to have one x left over. So here's what it would look like. You'd have 6x because 12 divided by 2 is 6. Because x to the power of 2 divided by x is simply x. and then there's 1y and 1y on the bottom as well, so that y completely goes away, minus 3. You have 6 divided by 2, which is 3, and then xy on both the bottom and the top, so those both go away completely. And then you have 2x over y, because you have 4 divided by 2, which is 2, and then you have x to the power of 2. Now you have one x that remains on the top, but that 4 did not have a y attached to it, so there is a y that remains on the bottom, so you're still left with a fraction. And that's how you do some dividing of polynomials. So I hope that helped you if you had any problems with polynomials or anything like that, and thanks for watching.